Okay, now we're going to introduce the definition and corollary. So the definition is of what we call matrix equivalence, okay, or matrix equivalent. So same-sized matrices, H and H hat, are matrix equivalent if there are non-singular matrices, P and Q, such that H hat is equal to P times H times Q. Okay. Now the corollary says this: matrix equivalent matrices represent the same map with respect to the appropriate pair of bases. Okay. Now the proof of this is evident from the equation that we saw in Theorem 1. So if you go back to Theorem 1, that equation is basically the proof that corollary 1, the result of corollary 1. Okay, so just to be reminded. Now, so here's the thing. Now, what we're setting up now is this idea of, just like we saw before with row equivalents, and we saw row equivalent classes, and we were able to partition the universe of row equivalents, right, in matrices or systems into different classes, and then we could have a representative of the entire class, right, which was the matrix in a reduced echelon form, right, or echelon form. And we're going to do the same thing here with matrix equivalents. We're going to make the connection, because now we can say, hey, maybe we could set up an H hat that represents each equivalent, a matrix equivalent class. Okay, so that's where we're going.